analogy by looking at the neuron. Your brain is full of neurons. Right now, neurons are firing. Your spine is full of neurons. Neurons are cells that communicate all through your body, and they look like this. So let's take a look at the parts, how they communicate, a little bit of chemistry, and what they call neurotransmitters. All right, here's the neuron. So when you look at it, it's going to send information. If someone touches your hand right now, neurons are going to go up your arm to your brain and tell you that you're being touched. Then when you want to move your fingers, neurons are going to go down, send messages, and then move your fingers. So neurons are going to send information. So here are the parts. This is a neuron, and this whole long thing here is called an axon. And the axon goes all the way to here, and axons send messages. Axons go at. Over here, but they have to touch, well, they have to send messages to one another. This part here is called the dendrite. This part will detect. So messages are going to get sent through the neuron. Dendrites will detect. Axons go at. Axons will send the messages. This tissue here is myelin, and it makes it fire faster. Think it's fast. It goes a mile in a minute. So these are the basic parts here. All right. Then in the end over here, the terminal button, terminar in Espanol, the end over here, let's go into that a little closer over here. All right, so the terminal button is here, and if you zoomed in here, you'd see this. This would be the terminal button, and this would be the end of one neuron, and then it's going to send a message to another one. So this would be the dendrite detecting the message. This would be the axon sending the message. Okay. Then, so there we go, that's that. Then a neuron is going to fire. And what that means is it's going to send the message. So a neuron will fire, it will send a message. That term is called action potential. And action potential is when a neuron fires and it sends a message. The term all or none is it either fires or it doesn't. There's no in between. All right. Now, a little bit of chemistry with the neuron. You see this plus minus stuff? These are chemicals. So a little bit of chemistry in the neuron. All right. First thing, neurons have sodium and potassium. And I'll give you a memory trick. Sodium is on the inside. Potassium is on the outside. Think of a potato chip. Okay? Potassium, potato on the inside. Sodium, salt on the outside. That's a little bit of chemistry there. Then there's something called depolarized. Okay, what does this mean? Put aside potassium, sodium. Now think of plus and minus. These are called chemicals called ions. Some are a plus, some are a minus. All right. What happens is when a neuron polarizes, that means that the pluses and the minus separate. I'm trying to find a picture of it for you. Is that a picture there? Trying to find a picture. Well, this might work. Okay. When it polarizes, the pluses and the minuses separate. And when they separate, oh, there we go. Here we go. Okay. So you have pluses and minuses. You can see it here. When it polarizes, they separate. And the pluses are up here, and the minuses are down here. This just happens. And then when it gets to a certain point, it doesn't like that, and the pluses will go into the neuron and depolarize. So polarized, just think of north and south pole. Pluses are up here, minuses are down here. Depolarized, the opposite will happen. And what's going to happen is this is polarized. Depolarized, the pluses are going to go into the neuron. I might have a picture somewhere. Polarized, depolarized. And what happens is that creates electricity. And so that's actually a neuron firing. That's electricity. Just like a battery has plus and minus and generates electricity, neurons actually generate electricity. And speaking of which, lightning works the same way. Lightning is the positives are up here, the negatives are down here. Nature doesn't like it. And when they come together, they collide and they create electricity. And the same thing happens with a neuron. All right, so you have potassium and sodium, and you have polarized and depolarized, and it creates electricity. All right, and it fires. That's the action potential. Then it reloads to fire again. And when it reloads, that's called the refractory period. And all it means is this, that process reverses, and the neuron can fire again. All right. All right. So now the neuron is fired. Um, let's go back in now, back to the neuron, and let's go to the synapse. Okay. So we just talked about the overall firing of the neuron. Now we're going to go back to the synapse or the gap. Okay. All right. That is one neuron. This is another neuron. They do not touch. There's a gap. See the gap? That's called the synaptic cleft or the synapse or the gap. They don't touch. Well, if they don't touch, how do neurons communicate with one another? They do with it something called a neurotransmitter. And a neurotransmitter is a small chemical that will cross from one neuron to another. Like a radio transmitter sends radio waves, neurotransmitters will send chemicals and let one neuron communicate with another. Now, if you look in here, there's little tiny chemicals and there's different neurotransmitters. And when they go across here, they try to fit into these little keys here, like these locks here. So this is the gap, and there's the axon, and there's the dendrite. Okay. So here's another picture here, maybe this is a little easier. Here is the axon, here is the dendrite, here's one neuron communicating with another neuron. All right. These little chemicals here are neurotransmitters. This neuron has just fired. It fires, and when it fires, it shoots chemicals over here. And these chemicals try to stick in here, and if they stick in here, they can make this neuron fire as well, and it can make it fire as well. And again, there's the gap, there's the dendrite, and these gaps fit like locks. There's different types of neurotransmitters that fit differently into these gaps. All right, and if enough of them fit, this neuron will make this neuron fire. All right, now a little bit more here. Neurons fire. It's kind of like a wave washing up on the beach, and the wave washes up, but then it also goes back. And when it goes back, some of this neurotransmitters go back here. That's called reuptake. So reuptake would be you send some neurons here, they don't fit into a gap, so they go back to the original. That is called reuptake. All right, what does this have to do with us? Well, neurotransmitters affect our mood, and one in particular is called serotonin. If you ever get grouchy because you're hungry, your serotonin is low. Psychologists have discovered, and so what is serotonin? Serotonin is a small chemical, a neurotransmitter. It's called serotonin. It gets fired, and what they've discovered is that depressed people have low serotonin. And what they discovered was that depressed people, they will shoot serotonin over here, and then it won't connect. So the serotonin won't fire, and it will go back to the original neuron. So what they've done is they have a drug for depressed people, and Zoloft, and there's many more. There's so many I can't even keep up with all the new ones. And it's a serotonin reuptake inhibitor. And what that means is everybody has serotonin, but they've discovered depressed people, the serotonin doesn't make it here, so it doesn't make it to here, so they're low in serotonin. So what they have is a serotonin reuptake inhibitor, and what that means is this. It's a drug you take, and your serotonin fires here, and the reuptake inhibitor, the drug blocks the gap, and the serotonin can't go back to the original neuron, so it goes to this one, and it increases your serotonin and increases your mood. All right, that's kind of an intro to the neuron and to neurotransmitters.